There we go. All right, so I didn't receive any emails this morning requesting help for any of the assignment. So these aren't lectures, these aren't lessons, these are office hours. So I don't have anything prepared. That said, don't forget your exam starts today and closes tomorrow. So you need to be taking this at the ELTC. So I'm going to get some work done this morning. I'm going to have the intermission screen up. I've got the chat open in case you got any questions. Otherwise, yeah, I'll see y'all tomorrow. One question I got asked for a measurement and then certainly how many sig figs we would use for the average. You would base it based off of, honestly, you use the decimal point of your least precise number. So if you had 2 decimal points for all your measurements, you would finish with 2 decimal points. Because so sig figs actually, the average comes from a summation, not multiplication. So the rule here is you go by the least precise number, so the number with the least number of decimal points, and that'll set the decimal points on your final answers. So for averages, it's not set by sig figs. It's not set by the sig figs of each individual number. It's actually set by the precision of each individual number because you're adding and dividing by the number of data points, and that number is infinitely precise. Is it possible to have zero significant figures? No, every number has to contain at least one significant figure, but that said, we can say a number is not significantly different from zero. So what that means is that if we carry the calculation out, ignoring all sig figs, so we take it out to infinite precision, and we look at the number, we may get a number, but that number, when we start looking at the significant figures, may end up just being 0.0 or 0 because the differences in the numbers we start with are so much smaller than our precision that in the end we really can't like get anything meaningful off of that. And that usually shows up with standard deviations a lot, where if you have really good precise numbers, your standard deviation ends up being 0. Highly unlikely, but it does occur. And when we start doing statistical analysis, this would be like a junior level quantitative chemistry course, they would actually go through how to prove if two numbers are different. And what you do is you look at the difference between the two numbers and you look at the uncertainty on the numbers. And what you can say is, well, the difference is non-zero, but in terms of how well we know those two numbers, that difference is smaller than the precision we have on those numbers. Therefore, we would say it's not significantly different than 0. So that's kind of like a long answer to your question. But generally speaking, no, you can't ever get like a, you can't get a, sorry, someone's trying to call in on me. You can't get a 0 significant figures. You can only get, you have to have at least one in any given number. What would we put for the lab? It would depend on the measurement you took. So if you, for like when you were measuring the volumes, you would look at the precision on the volume. So if it was precise to 1 decimal point, your average would have 1 decimal point. If it was precise to 2 decimal points, your final answer would have 2 decimal points. Mass would work the same way. I think their scales they give you in the kits are 2 decimal points, so your average should have 2 decimal points. So the thing about sig figs, and a lot of students get this wrong, misconception about sig figs is you don't tell a measurement how precise it is. So you measure to whatever the scale or the volume tells you, and this is typically going to set your averages because your averages are usually just those numbers. Now, exceptions to this are things like density. With density, you're going to have to work out the sig figs for the density because your mass and volume may not necessarily have the same precisions. So the same number of sig figs in the actual number. But in terms of the actual like sig figs in the final answer, it's going to match whatever decimal points you had in your densities. Because again, with averages, you're adding, and the rule with adding is that it doesn't matter how many sig figs are in the number, it's a matter of how many decimal points were in your answer. Conversion factor guide. So on the exam, you're not going to be given conversion factors, but that said, we're not going to focus on imperial units, so it's only metric conversions on the exam. The imperial conversions to metric to imperial is going to be your inches, feet, yards, things like that, pounds. We do that just to create problems. In this course, though, we're only going to focus on the SI, the System International Units, which are all the metric units. And so for those, you need to know how to convert. So you need to be able to go from meter to kilometers, meters to millimeters, milliliters to centimeters, and also for grams to milligrams, grams to kilograms. And the other one, let's see here, meter and volume, liters, milliliters. Those are typically the only two units of volume we work in. But you should be pretty comfortable working with the metric system. I would recommend memorizing the metric staircase. It's a pretty good way to quickly memorize. Like you move a decimal point for each step you take on the staircase. And yeah, so yeah, you're not going to be given a conversion factor because we're not going to be working with imperial units on any exams. It's fair game to be able to do conversions in the metric system, but the metric system is just purely designed so this way it's always some power of 10. So 1 meter is 100 centimeters, 1 meter is 1,000 millimeters, 1,000 meters is 1 kilometer. You're welcome. Sorry, laptop crashed on me. It's been a while trying to get this thing back up and running again, but looks like it's running. I unfortunately don't see any questions in the chat. So again, if you have any questions, please feel free to email them in advance. Otherwise, good luck on your exam today and tomorrow, and I will see y'all tomorrow for office hours.